Hello everybody. So we're going to go back to our trig ratios. So I have some information on the very top that you may want to copy down, or if you kept notes you can go back and look at your notes. So on the trig ratios, I need you to remember SOHCAHTOA. Some old hippie called another hippie tripping on apples, or what it really means is sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent is opposite over adjacent. This is going to help you with classwork number 13, which I'm giving you tomorrow, which is Wednesday, because I'm videotaping today, Tuesday. Just think, I'm going to walk outside the door and go mow my yard. Who'd ever thunk it? Okay, another thing you need to know, this is way from the past, is you need to know the Pythagorean theorem today, which I know you learned in geometry because you have such great geometry teachers in Jupiter High School. So the Pythagorean theorem is for right triangles only, and it's a squared plus b squared equals c squared. And of course c equals your hypotenuse, but it's also, in what we're going to do today, it's your radius of a circle, which that's why we call it a unit circle, because your radius is 1 unit long, no matter what the length of it really is. One more bit of information: when you made your ordered pairs around the unit circle, your x and y is always your c then s. C stands for cosine, s stands for sine, and then we haven't worked on this a lot, but to find tangent when you're doing trig ratios, but on a unit circle, to find tangent, you have to take sine divided by cosine. That means whatever your y value is in the ordered pair, you divide it by your x value in an ordered pair. So this is what your worksheet's going to look like, and I know you probably can't read that, but that's what a direction on your worksheet that you could print before you started the notes. And so on number 1 example I'm going to do for you, it says find the sine of theta when the terminal side of theta passes through the point -12, 5. Okay, so you're probably going, whoa. All right, so the first thing you do is you look and you go, okay, where is the point -12, 5? So if I go here, and you don't have to be exact, so I'm not going to use my actual graph on this, like count -12, 5. I'm just going to go -12, 5. I would know I would go left -12 and up 5. So I would have a point somewhere over here. Okay, so that's where -12, 5. It'd be over here in quadrant 2. So, and by the way, in quadrant 2, if I think, all seniors turn crazy, especially this year in 2020, in quadrant 2, I know that S, all seniors, sign means my answer's got to be positive, because I'm looking for sign. So when I go left -12, I'm going to make a triangle here. I'm going to make a right triangle. And remember, your radius is always your hypotenuse. So you always make a triangle this way. And then your theta is always from your origin. Always from your origin. So you always put your theta symbol there. So your hypotenuse is always your radius. Yes. And so you make sure you make the diagonal this way. So now I have my right triangle. And so I can go, okay, well, -12 is here. And then up 5 was here. So if I want to find the sine of theta, so sine is opposite over hypotenuse. So I have to find the hypotenuse. That's why you need to know the Pythagorean theorem. So remember, this is your A, this is your B, so you would go 5 squared plus -12 squared equals c squared, but this time I'm going to put r squared because it's your radius, which is your hypotenuse. So if you do the math, you get 25 plus 144 equals r squared. When you add the two together, of course I'm running out of room, sorry, you would get 169 equals r squared, and then your last step is the square root, both sides, so your radius equals 13. Now you don't put plus and minus here because we're talking distance, and distance is never negative. So I know my hypotenuse here is 13. Isn't that nice? It's a perfect square root. So now I can find the sine of this, the sine of my theta. So sine is opposite, so opposite my theta is 5. My hypotenuse is 13, and let me just mark this for you. So this would be your opposite, this would be your adjacent, and this is your hypotenuse. So if I want the sine of this angle, I would go opposite over hypotenuse. So my answer would be sine of theta equals 5 over 13. And there's your answer. Okay, so look, my answer is positive. Perfect. All right, so that's not, I hope, too bad. So you had to use the Pythagorean theorem. And by the way, because my answer was a perfect square root, this is called, these three numbers here are called a Pythagorean triple. So I don't know if you remember in that geometry, when you have three numbers that actually a squared plus b squared equals c squared exactly, no decimal answer, and it's a perfect square root, that's called a Pythagorean triple. Just like 3, 4, 5, 3 squared plus 4 squared does equal 5 squared, that's a Pythagorean triple. Okay? All right, so let's just go on to number 2. So on your worksheet, they also give you one where they actually draw the hypotenuse for you. So they actually give you the theta. They go, okay, so your point is at -4, -5, so left 4, down 5. So all you have to do now, isn't that nice? They give you the straight line. They give you your radius. You just have to go like this. So you write your right triangle, and then let's mark it. So I went left 4, down 5 to get to that point. And then I need to do and find the hypotenuse for this because I need cosine. Remember, cosine is adjacent over hypotenuse. So I got to do the Pythagorean theorem again. So if I do the Pythagorean theorem, so if I go -4 squared plus -5 squared equals c squared or r squared, however you want to do it, you get 16 plus 25 equals 41. Oh, I gave you the answer. What a goober. Goober. Okay, I'm a goober. That's going to be your answer. So then when you add them together, you get 41 equals r squared. And then when you square root both sides, you cannot simplify 41. So your radius is the square root of 41, and do not change it to a decimal. Leave it as a radical 41, a square root of 41. So I know my hypotenuse here is radical 41. Okay, and don't put a negative here. Okay, so then now I can answer that question. So cosine is adjacent over hypotenuse. Remember, your theta is from your origin. So adjacent would be -4, which makes sense because all seniors turn crazy. Only tangent is positive here, over radical 41. So let's see where I can find some good room to do this. All right, so right here for this one. So this would be -4 over radical 41. So that looks like my answer so far, doesn't it? But no, it's not. Because what's wrong? You can't leave a radical in the denominator. So when we rationalize the denominator, I'm going to multiply the top and bottom by radical 41. So my final answer would be -4 square root of 41 over 41. And you look to see if those can be simplified, but they cannot. So this would be your final answer for this one. Okay, so these two are very similar. The only thing is they drew your radius for you. All right, so let me move this up a little bit. On number 3, it says find the tangent of theta that passes through this point, -1, 0. Okay, wait a minute. -1, 0, left 1, 0. I can't make a triangle out of that. It's quadrantal. It's right on the x-axis. Actually, this is my favorite kind because as I wrote, it's on the top of the worksheet now. to find tangent, tangent is sine over cosine. So let's look at that ordered pair. Remember, it goes cosine sine. So to find the answer to that one, you just have to go sine, which is 0, divided by cosine, which is -1. Well, my equal and my line ran in together, sorry. So what's 0 divided by -1? 0. So my answer for this one, so my tangent of theta equals 0. Those are my favorite. You don't have to do Pythagorean theorem. You don't have to do anything. So to find tangent, it's just sine divided by cosine. That's all we did. Sine divided by cosine. That's it. You do have one of those, so that would be nice. Okay, so then the last thing I want to show you is on number 10, and I'm doing number 10 from your worksheet because this is kind of weird the way it's stated. So on this number 10, it says, in what state the quadrant, so you're just writing a quadrant number, where sine is greater than 0, that means your sine is positive, and your cosine of theta is less than 0. Well, here's how it helps me to do this. I go, okay, wait a minute. Your sine is your y values, and your cosine are your x values. So I sit here and I take my finger and I go, okay, where are my y's positive? Okay, my y's are positive up here. So that would be up. And then because greater than 0. Then here, where are my x's negative? Well, my x values are negative if I go left. So if I go up and left, what quadrant does that be? What quadrant is that in? Well, obviously, it's in quadrant 2. So that satisfies both of my restrictions right there. And that's your answer. That's it, peeps. Hope that helps. No one's coming to meet. Would y'all just pop in and say hello to me sometimes? I'd like to see your faces. I never get to teach you again in class, so y'all could come and see me on Meet. Peace out. I'm going to go mow the yard. Bye.